So welcome everybody to this latest video 162 Maths, and in this video we'll be going over GCSE Maths topic of arc length and sector area. Now before going through some past exam questions which will include a mega 7-mark question, I will go through exactly what you need to revise for this particular topic. Now a copy of the questions that we go through in this video are available for you to download by clicking on the link in the description. Now before we get started working through some arc length and sector area questions, let's just have a quick overview over what it is you've actually got to revise. Now in terms of the formulas for arc length and sector area, you do need to revise these formulas as they are not given in the exam. So again, this is going to be a set of formulas that won't be attached to any of the questions, like surface area and volume of a 3D complex shape, or a non-prism shape I should say. So they do need to be learnt. Now in terms of the formulas, now if you're quite apprehensive about revising these formulas, then do not worry, because the key thing is that you need to remember what part of the circle each part is connected to. So for example, arc length is connected to the circumference of a circle. Now hopefully you know that the circumference of a circle is pi times d, or 2 pi r. Now in this particular topic we tend to use 2 pi r more often than pi times d, only because we just want to use one letter. So mixing radius and diameters is a lot of faff, but again not impossible to work with. So you tend to find that with arc length the radius version of the circumference of a circle is going to be given. Then once you know that it's connected to the circumference, the only thing you then need to revise or remember is this theta over 360, which is basically the proportion of the circle that the sector is part of. Then once you've known that, so the arc length is just, now remember that the arc length is just the part of the circumference, not the entire perimeter of the shape. The perimeter of the shape is basically the arc length, which is this bit here, and then we've got the 2 radiuses, which is the 2 straight edges. And again, the perimeter, you don't need to revise this formula. The perimeter is just all the lengths added together. So here you've got 2 r's and the arc length, so that's where that formula is derived from. Then when it comes to sector area, again, area is connected to the area of a circle. The formula for the area of a circle is pi r squared. So again, the only thing you need to remember is to multiply that by theta over 360. Now, a little quick note that this topic can come up in both the non-calculate and the calculate paper. Although the formulas look very, very confusing and quite complex, you may have to give your answer in terms of pi. So make sure that you're familiar with working with fractions and you're able to multiply fractions by whole numbers, because that's going to be really, really important when dealing with the non-calculated versions of these questions. When it's on a calculator paper, just make sure that you are showing full working out, showing that you've used the formulas correctly. You won't necessarily get a mark for quoting the formulas, but you will get marks for using those formulas, so substitute the values in. Now in terms of other topics that arc length and sector area is connected to, obviously going to be connected to area and perimeter, and often it's related to shaded area questions, but it's also linked to trigonometry, circles, pie charts, proportions and fractions. So always be mindful that these topics could be included in a particular question. So without further ado, let's get started on these exam questions. Now again, a little reminder, if you want an access to these questions, all you need to do is just simply click on the link in the description below and you can download these questions absolutely for free. So looking at question 1, it says the diagram shows a sector of the circle with a radius of 24, and the question is asking us to work out the arc length of AB. So in other words, it's asking us just to work out this length here. Now note it's just asking for the arc length, not the perimeter of the shape, so do not go that extra step further. So looking at arc length, it's worth quoting the formula, which is theta over 360 multiplied by 2 pi r. So again, substituting numbers in, I know theta is 45 and the radius is 24. So substituting those numbers in, I get 45 over 360 multiplied by 2 multiplied by pi multiplied by r. Now, just remember that with regards to this bit here, is you've got a fraction and you've got numbers being multiplied by that fraction. So if you want, what you could do is put brackets around the 2 pi r and have that over 1, so you're dealing with a multiplication of 2 fractions. But if that doesn't bother you, then you should be okay. Now one thing I have noticed that I need to replace the r with the actual value, which in this case is 24. So then working this out, now 45 divided by 360 is 1/8. Multiplied by 2 times 24, which is 48, so it's going to be 48 pi over 1. So then if I just multiply that out, now if this was on a calculator, I could put it straight into my calculator, but I'm going to assume that all of these questions are non-calculator unless I desperately need a calculator. And it kind of just encourages, if you approach every question as a non-calculator question, it just encourages you to show full working out, but it may take you a little bit longer. So then working this out, 48 does go into 8, and that's going to be 6. So the answer then, in terms of pi, is 6 pi, or it's going to give me an answer of 18.8, and that's to 1 decimal place. So then moving on to question 2, it says 2 identical quarter circles are cut from a rectangle as shown, and the question is asking us to work out the shaded area. Now with most shaded area questions, it's always the big shape, take away the small shape. So the shaded areas here is going to be equal to the area of the rectangle minus the area of 2 lots of a quarter circle. So this is what I need to work out first. So looking at the area of a rectangle, now looking at this is 20. Now this is basically the radius of a circle, and that's another radius. So that means that the radius has got to be 10. So that means that this length here is also going to be 10. So then the area of the rectangle is going to be 20 times 10, which is 200. And again, I'm just going to put a little box around that, as that is this bit here. So then what's left for me to do is work out the area of the quarter circle. Now the area of a full circle is pi r squared, so a quarter circle is going to be pi r squared over 4. So substituting numbers in, I get pi times 10 squared divided by 4. 10 squared is 100, so it's 100 pi over 4, which gives me an answer of 25 pi. So then, if I just put a little box around that. So then working at the shaded area, and let's just do that here. So the shaded area is going to be, let me just scroll down a little bit so we get a bit more space. So the shaded area, actually let's zoom out so we can see it. So shaded area is going to be 200 minus 2 lots of 25 pi. So then working that out, now leaving my answer in terms of pi is going to be this, or I could just type that into my calculator and I get an answer of 42.9, and that's going to be centimeters squared, and that's been rounded up to 1 decimal place. Then moving on to question 3, it says that an allotment is in the shape of a major sector of a circle with radius of 5 meters. A gardener wants to place a fence around the perimeter of the allotment. Fencing is sold in 1 meter lengths. How many meters of fencing will the gardener need to have to buy? So looking at this, the first thing we need to do is basically work out what the major arc length is going to be. Now, even though it's a major arc length, it's still the same formula. So it's still theta over 360 multiplied by 2 times pi times r. Now, this length, this angle here is going to be 360 take away 60, which is 300. So from this, I can then work out what the arc length is going to be. And again, that's going to be 300 over 360 multiplied by 2 times pi times 5. So then working with this fraction, I can take the zeros off, so that's 30 over 36, divide both numbers by 6, so that becomes 5 over 6, and 2 pi times 5 is 10 pi. So that then becomes 50 pi over 6. So this length here is 50 pi over 6. Now the next thing for me then to do is to add the 2 other lengths. So then the perimeter is going to be 50 pi over 6 plus 5 plus 5, so that's 50 pi over 6 plus 10. And if I type that all into my calculator, I get an answer of 36.179. And so rounded up to the nearest meter, I'm going to need 37 meters of fencing. Then moving on to question 4, I'll zoom in for this one because I can actually see it on the screen. Now this one's asking for our answer in terms of pi, so this is going to be a non-calculated question more often. So looking at this, it says the diagram shows a sector of a circle with a radius of 5. The area of the sector is 5 pi. Work out the arc length. Give your answer in terms of pi. Now for this, we don't know what theta is, so in order to work out the arc length, what I need to do is I need to find theta first. Now in order to do that, what I'm going to do is I know this bit of information. So what I know is that theta over 360 times pi times the radius squared equals 5 pi. Now I know that the radius is 5, so I can change that for 25. So if I take all of this over to this side, just to create a bit more space, I've got theta 360 multiplied by 25 pi equals 5 pi. Now if I take the 25 pi over to the side, I end up with theta over 360 equals 5 pi divided by 25 pi. Then from this I can cancel the 5 and I can cancel the pi. So then all that's left is theta over 360 equals 1/5. Then if I do cross multiply, I end up with 5 theta equals 360, so theta equals 72. So then once I know that theta equals 72, I can then work out the arc length, which is theta over 360 times 2 times pi times r. So then that then becomes 72 over 360 multiplied by 2 multiplied by pi multiplied by 5. So then simplifying this fraction here, what I end up with is, well, let's work that out. So I've got 72 over 360 multiplied by 10 pi, and then so that then becomes 720 pi over 30 or 360. And again, if you're not sure about how I've got that, just turn the 10 pi into a fraction, and then I could then simplify 720 over 360, which just gives me an answer of 2 pi, and that's going to be in centimeters. Then moving on to question 5, it says the diagram shows a sector of radius of 4 centimeters. The perimeter of the sector is 12 centimeters. Work out the size of angle X. So again, looking at this, we know that the perimeter of the shape is going to be theta over 360 multiplied by 2 times pi times the radius, which is 4, and I then need to add 2 lots of 4, which is the 2r. So then if I just put brackets around this, because I don't want to get confused between what's being multiplied and what's being added. So here I've got x over 360 multiplied by 8 pi plus 8. And all of this equals 12, because it says the perimeter is 12. So simplifying this further, what I end up with is 8 pi x over 360 plus 8 equals 12. Take the 8 over, so that becomes 8 pi x over 360 equals 4. And then doing a bit of solving the equation, I can take the 360 over to the side, so 8 pi x equals 4 times 360, which is going to be 1440, and then I can take the 8 pi over to the other side, so it's 1440 divided by 8 pi, and that gives me an answer of 57.3, and that's to 1 decimal place. Then moving on to question 6, it says the distance from Earth to the Sun is 93 million miles. And it says, assume that it takes 365 days for the Earth to travel once around the Sun. The Earth travels in a circle with the Sun as the centre. Calculate the distance travelled by Earth in 1 hour. Now, with this, if I just imagine this is the Sun and this is Earth, and we know that it's going to go in a circle. Excuse the dodgy circle there. And we can see that the radius between there is 93 million. So what I need to do is I need to work out what the total circumference is. So the circumference, which is 2 pi or pi times d, is going to be pi times, and it's going to be 2 times, actually let's write the formula properly. So let's go for 2 times pi times the radius, which is 93 times 10 to the power of 6. Now if I type that all into my calculator, I get an answer of 5484336 and that's miles, and that's in 365 days. So now if I divide that number by 365, then what I get is I get 1600921.188 miles in 1 day. And 1 day consists of 24 hours. So then if I then divide that number by 24, I get 66705.049, and that's miles in 1 hour, which is what they wanted me to find out. And again, if you want to round that number up to any degree of accuracy, that's entirely up to you. Then moving on to 6b, it says it actually takes 365.25 days for the Earth to travel once around the Sun. How does this affect your answer in part A? Well, if the time is increasing, then that means it's going to travel less miles. Then moving on to question 7, it says here are 2 sectors from different circles. Which sector has a bigger perimeter given that x is less than 180? And it says tick a box, section A or B, and it's a massive 7-mark question. So let me zoom out because obviously this is going to require a fair bit of working out, and notice how the question resets. So let's just go back to it. So we've got this particular question. So for this, it's all about working out the areas from each of the separate sections. And again, you will need a bit of space. And again, in the exam, if you did have this, you could ask for additional sheets of paper if you've used up all the space. So if we look at sector A, now the formula for the area, for the perimeter, sorry, is going to be theta over 360 times 2 pi r plus 2r. This is the formula that we're going to be using. So then, working out the sector of A, well, here I know that the angle is x, and dividing that by 360, and then going to multiply that by 2 times pi, and the radius for this is 1.5r. And then I'm going to add, so if I just put that in brackets, I'm going to add 2 lots of the radius, which if I just do that now, it's going to be 3r. So then just neatening all of this up, I end up with, well, 2 times 1.5 is 3. So that's going to be 3 pi rx divided by 360, and that's going to be plus 3r. Now again, I could neaten that up, but I'm just going to leave it for this for the time being. Well, let's simplify it now. So we've got pi rx over 120 plus 3r. I'm just going to put a little box around that. Then doing the same, but this time for sector B. So again, working at the perimeter, this time the theta is 2x, so it's 2x over 360 multiplied by 2 times pi times single r, and we're adding 2 r's to it. So again, simplifying this bracket here, we've got 2x times 2 times pi times r, which gives me 4 pi rx over 360 plus 2r, which if I simplify the 4 and the 360, I'm going to get pi rx over 90 plus 2r. Now what I need to do is I need to compare the green box with the blue box. Now at the moment it's really difficult to me to compare because one, I don't know what x is and I don't know what r is. So there is an issue. Now you might think to yourself, well, if I substitute values of r, let's just make up a value, then I can then work out what the angles are going to be and what the perimeter is going to be, which I'll be honest is actually a good tactic you could do. However, what you might want to do is to prove this algebraically. So what you could do is sub the same value, well actually let's scrap that. What you could do is pick a value of x. Remember that x has got to be less than 180. Pick a value of r and then sub into each box and see which one is going to be set, because r is the same in both the two equations and so is x. So regardless of what they are, it will then be able to give you a ratio. Now it won't be able to give you the exact perimeter, but it will definitely give you some comparison about which one's bigger and which one's not. Now if you didn't want to go for that option, let's say you want to prove it algebraically. So if I just write a here and let's just write down what a is. So that was pi rx over 120 plus 3r, and b was pi rx over 90 plus 2r. And if I then just write the 3r and the 2r as fractions, so let me just write that over 1. And actually, let me just put that in blue. Then if I multiply a by 2 over 2, and I multiply b by 3 over 3, so technically I'm just multiplying by 1, so I'm not going to change the value. All I'm going to do is just change the numbers and find an equivalent fraction. Then this then becomes 2 pi rx over 240 plus 6r, and this is going to become 3 pi rx over 3 times 90, which is 270, and that's going to be plus 6r. Now as you can see in this, that we're both adding 6r in both the same, so what we can then do is basically focus on these two things here. Now if I simplify this one here, and again this is looking an absolute mess, but if I simplify that, then that's going to be pi rx over 120, and this is going to be pi rx over 90. Now out of these two, because I'm adding the same amount, that doesn't make a difference, so the fraction part is the bit that's going to decide whether it's bigger or smaller. Now this one is clearly going to be the bigger one, as the denominator is smaller. So therefore this fraction is always going to give me, if x is and r are the same values in both fractions, then this fraction here is always going to be bigger because I'm dividing by a smaller number. So therefore, long story short, sector B is going to be the bigger of the perimeters.